In the universe, everything is great. The vastness of space, the invisible forces that shape galaxies, and the almost unimaginable number of stars that shine silently in the immensity. Scientists estimate that there are about 2 trillion known galaxies. In each of them, there are, on average, 1 billion stars. It's such an absurd amount that mathematics itself seems to run out of steam in the face of such a scale. But behind these colossal numbers, there is something even more surprising: rarity. Among billions and billions of stars, some are so unique, so exceptional, that we can barely understand them. They do not fit into the models we know. They defy the laws of physics, the logic of astronomy, and often their own imagination. What happens to a star after it burns all its fuel? It depends, and it all revolves around a single variable: mass. The amount of matter that forms a star determines how it lives and, most importantly, how it dies. Stars like our Sun, for example, have a relatively calm fate. They expand, transform into red giants, and end up releasing their outer layers into space, leaving behind an incredibly dense core, the so-called white dwarf, a small bright spot the size of Earth, but with a density so high that a teaspoon of its matter could weigh tons. Stars with more mass live more intensely and die spectacularly. They collapse, explode as supernovae, and leave behind either a neutron star or, if they are big enough, a black hole. Neutron stars are especially curious. Small, dense, made up almost exclusively of neutrons. A world where atoms have literally been crushed. But within this exotic universe, there are even stranger stars. One of them is what astronomers call a pulsar, a special type of neutron star that spins at very high speed and emits beams of radiation from its magnetic poles, like a cosmic lighthouse spinning in the void of space. These pulses can be as regular as the ticking of an atomic clock. So far, so good. But what if I told you that there is something between a white dwarf and a pulsar? A celestial body that should not, by known rules, be capable of emitting radiation like a pulsar, but it does. A pulsating white dwarf. That's exactly what astronomers discovered when observing a star called R Scorpii. Located about 380 light-years from Earth, it looked like an ordinary white dwarf. But upon investigating it further, scientists noticed something strange. It was emitting radiation much like a pulsar. The problem? This shouldn't be possible. A white dwarf is too big to spin that fast on its own. Its mass does not allow for such violent acceleration. So how did this happen? The answer lay in a companion star, a small nearby star that orbits the white dwarf every 3 hours. This interaction between the two stars created an environment so extreme that it accelerated the white dwarf to the point where it began to emit radiation from its poles, a phenomenon never observed before. For a time, R Scorpii was considered the only example of this type of star in the universe. But in 2023, a new discovery further challenged the limits of astronomy. A similar star called J19124410 was identified. This raises the possibility that perhaps there are others out there, rare, silent, hidden in the cosmic shadows, waiting to be discovered. These unique cases show that the universe still holds secrets capable of turning our certainties inside out, and it doesn't stop there. Now imagine a star that coughs. Yes, you heard right. Cough. And every time this happens, she releases dust as if she were smoking. It's not a joke. This peculiar phenomenon was discovered recently, and astronomers, in their scientific good humor, nicknamed these stars old smokers. These stars are ancient red giants located in the heart of the Milky Way. For years, scientists observed strange behavior. They glowed, then dimmed, as if a cloud covered their light, and then glowed again. Something was blocking the radiation. The investigation lasted more than a decade, Using powerful telescopes in Chile, researchers discovered that these stars were so cool that material in their atmospheres was beginning to condense and form dust. This dark dust was then expelled, temporarily obscuring the star's light, as if it were coughing up smoke. After the cough, the star shone again. An unusual behavior, but one that could reveal clues about the early days of the galaxy. These old smokers may have been responsible for releasing heavy elements into the universe, fundamental ingredients for the formation of planets and even life. And as if that weren't already rare enough, there's yet another type of star that seems to defy all the rules. R-type variables, coronae borealis. These stars have even more unpredictable behavior. Unlike most variable stars, which follow a rhythmic pattern of brightness and darkness, our coronae borealis can go out almost completely, out of nowhere. No warning. Suddenly, its brightness plummets, and then, weeks or months later, it returns to normal, as if nothing had happened. The cause? The answer lies in the chemical composition of these stars. They have an almost insignificant amount of hydrogen, something very rare. Instead, their atmospheres are dominated by helium and carbon. When the carbon produced inside rises to the surface and cools, it forms a cloud of carbon dust that blocks the star's light. This cloud is dense enough to make the star invisible for a while, and then, slowly, the dust dissipates. These events do not follow any fixed pattern. They are unpredictable, and this behavior only reinforces the rarity of these stars. Since 1795, only about 30 stars of this type have been identified, and among them there is an even rarer subcategory, the so-called dy Persei type variables, only 6 known in the entire observable universe. If there's anything these discoveries teach us, it's that the universe doesn't follow a script. It is dynamic, changeable, and constantly surprises us. For every rule we set, he seems to create an exception, and perhaps that's what makes it so fascinating. As telescopes scan the skies, perhaps right now, a new pulsating white dwarf is accelerating alongside a companion star. Perhaps an old smoker is releasing dust in the far reaches of a distant galaxy. Maybe a star is about to disappear without explanation, and then reappear days later. The cosmos is a book that never closes, and each discovery is a new page turned, revealing that we know much less than we think. And that's wonderful, because as long as there are mysteries in the sky, there will always be something worth looking at, studying, and being enchanted.